Hello everybody, my name is Justin Telmo, and I'll be going over my Lab 1 for CMPS 160. This first lab is called Painterly Rendering. You would take an image and use OpenGL to simulate painting it, not exactly painting it as accurately as the picture itself, but we're going to go over how I did, at least, all of the criteria as you see here. Not all of these criteria are accounted for, but I do know how to do them. If I would fix my program, I only did one submission, but we're going to go over all of these. So the first thing we're going to go over is loading an image file named on the command line, and we're going to go back into our code, or rather go into our code for the first time, and see that inside ppm canvas cpp we have this function called ppm load canvas. So what's going to happen is ppm load canvas takes in a file name, which is a character array, as well as a canvas t. A canvas t in this lab, I believe, is just representation of the window, so where the pixels are going to be read into. So load canvas actually takes a file in, called it fp, and here we have this little statement: if fp equals fopen file name rb equals null, then return 1. Fopen opens the file and reads it as a text and binary file. So what happens is it checks the file name, if there is a file name. This is just a general case file name, and if there isn't one, it returns -1 and the program exits. Otherwise, it takes the canvas that's given. Canvas is another struct inside of ppm canvas. It takes the attributes of whatever image you seem to pass in is in through a ppm file, and gives it the attributes that will correspond to the rendering part of your Painterly rendering. So right here we have width and height, and we have this thing called pixels. Now we all know that the Painterly rendering is basically an array of pixels, a 2D array of pixels, I believe. So we need to create space for all of these, which is why we use malloc. But that takes care of reading in a file name from the command line. The next thing we're going to be talking about is displaying a help message about what the mouse and keyboard do. Now that is relatively easy. We go into our main program here. We scroll all the way down to the main, and since we can use the command line actually as the means of displaying our help options, we can go all the way down here to main, where we have a series of print statements. As you can see here, let's just go over mine really quickly. Welcome to Justin Telmo's Painterly rendering program. Of course, if you're going to be using separate lines, you would need a new line after every printf statement. So let's just go through the commands. We have Z to increase brush size, X to decrease brush size, E to enter eraser mode, which I will explain later, M to change brush mode, A to autofill a canvas with the image, C to clear the canvas, Y to invert the colors of the image, and Q to quit the program. As you can see here, we also add a couple additional could be used as debug statements for the width and the height of the canvas or image that you're using. Now we're going to look over how to present a window slash the blank canvas. I'm sorry. Inside of Lab 1, we have a function here. I will just look for it actually. Here we go. Glut. Inside of main, we have this little thing here. We have glut init window size, canvas.width, and canvas.height. As you can see here, canvas is passed in as a global, so no matter what, canvas will be defined as something as long as there's a ppm file to be read in. But it takes the width and height of the canvas and creates a blank slate, basically a black screen, and that is the canvas on which you begin to paint. And as you can see here, we have GL clear color. GL clear color actually makes it such that the background image is some RGBA value, which is a vec4 in this case. So we have it set to 0, 0, 0, 0, as you can see here, the Visual Studio actually confirming this. So we have red, green, and blue, and alpha set to all zeros. So we're going to be left with a black screen on initialization. So that's how you get the window. Now here is where it gets a little complicated. Now we're going to go over how to draw a correctly colored triangle when you click. Now what this means by correctly colored is that it corresponds somewhat somewhat closely, I'm sorry, I'm a little sick, somewhat closely to the original image. So to demonstrate, I will actually go into the program right now. First, let's autofill the image. So that's what the image would look like. This is the image that I basically passed in. It's a noise, it's noise and stuff. I think it's the height map for lab 3, I believe. So let's just go ahead and clear that, and you get to see what I'm talking about. As you can see, if I start coloring, why can't I start coloring? That is a problem. Anyway, this is the problem with doing it one take. It's it's always gonna end up with a lot of weird things. Anyway, so here we go. We have the mouse position corresponding to somewhere in the pixel array, and draws a color using using ppm load canvas and whatever function you use to draw the, in this case, squares. So let's go back into the code. As you can see here, we have a bunch of functions: draw quads, points, triangles, and polygons. Let's take a look at draw quads. Here we have a pixel t pix. Now a pixel t, I believe the struct is inside here. So here we have ppm canvas h. So we have definition for pixel cxy as this function c.pixels of x plus c dot width times y, which basically puts the color at some point in the corresponding ppm image. And so what happens is